The first question, you're supposed to find the size of O1. Okay? Now, O1 is an angle between a transversal OC. Okay? There is a transversal OC which connects two lines that are parallel. That is, OF is parallel to BC. Therefore, O1 is going to be equal to 20 degrees. And the reason they alternate angles, and you have to state the lines that are parallel. So OF is parallel to BC. Okay? So this was pretty straightforward. So this was a straightforward question. Then D1, yes?
What if you say ON is parallel to
Or what?
ON? Just like they said.
Yeah, it's fine because point O, N, and F, they are collinear, so it's okay. Alright, then D1 is that angle. It's an angle at the circumference. Right? Angle O1 is subtended by the same chord, and that chord is going to be called NC or arc NC. Okay? So both angles are subtended by the same chord, but one is at the center, the other one is at the circumference. So D1 is going to be equal to half of O1. And the reason angle at center is equal to angle at center is equal to 2 times angle at circumference. Okay, so D1 will be equal to 10 degrees. Okay, angle D1 is equal to 10 degrees using theorem 2. Angle at center is 2 times angle at the circumference. Right? Then 8.1.3, right? C, that's C2. Okay, C2 is here. This is C2, that angle there. Okay? So C2 is an angle between DC and BC. Okay? Now, if you want to find that angle there, you have to identify a cyclic quad. So, we've got cyclic quad A, B, C, D. So, the opposite angles must add up to 180 degrees. Okay? So, we'll say angle A plus C2 plus C3, they should add up to 180. And your reason there, it will be opposite angles of a cyclic quad. Okay? Okay. How did you say it? Opposite angles of a cyclic quad are supplemented by squares.
So, is it okay if you didn't say angle C2 and C3, but you just said BC and
Yeah, it's fine. Okay, you can call C2 plus C3, you can call it BCD. It's also the same. So C2 is going to be equal to 180 minus 150 minus 20 degrees, and you get 10 degrees. Okay? So C2 is equal to 10 degrees. Okay? Any question there? Any question? Right? So you must give yourself a mark for the statement and the reason. Or you can give yourself a mark for the reason and the answer. The answer is like the statement. Alright? Then we move on to the next one. This one here. Right? You needed to find the size of D2. So D2 is this angle here. Okay? Now, to find D2, okay, I hope you're all aware that this angle here, that angle C4, is equal to D2. It's an angle between a tangent and a chord, and the chord subtends angle D2 at the circumference. So you can use tan chord there. Usually, going forward, if you see a question with no tangents out, with no two tangents from a common, starting from a common point outside the circle, then you throw away theorems, theorem 8. If also, the moment you see a tangent like this, in most cases you have to use the tan chord theorem. If there's a radius, like in this case there's a radius, OC, it's a radius, it means you have to use theorem 7. Okay? The moment you see a tangent, if there's only one tangent, then it's likely theorem 7 or theorem 9. There is no need to get confused. Okay? Either theorem 7 or theorem 9. If there's a radius or a diameter, then you have to use theorem 7. If the radius of the diameter is not there, then it's supposed to be theorem 9, which is the famous tan chord theorem. Okay? So, C4 is going to be equal to D2. But what is the value of C4? Well, it's very easy to find. Can you pay attention and stop that? Stop that. Okay? So, we'll start by saying, now it's 4 marks here. You need to write things properly. So first thing, I'm going to say OC is perpendicular to OC is perpendicular to, okay, I'm not going to write that. Let me just write this and say that angle there, OCG, is equal to 90 degrees. My reason here is tan perpendicular to radius. Okay? OCG is equal to 90 degrees. Okay? It's an angle between a radius and a tangent. Okay? The tangent is perpendicular to the radius. But OCG is equal to C3 plus C4. So this is equal to C3 plus C4 is equal to 90. Fortunately, I know what C3 is. So C4 is going to be equal to 90 minus 20, and you get 70 degrees. Okay? But if you look at it carefully, as I said earlier, C4 is equal to D2. That's the tan chord theorem. So I'll say, therefore, D2 is equal to C4, both are equal to 70, and my reason will be tan chord theorem. Okay, and then I'm done. Right? Done. Okay, so in terms of mark allocation, obviously for knowing the value for getting the correct value of D2, that's 1 mark, there isn't 1 mark. Then we'll give a mark here for that reason, and I'll also give it for this statement. So you get your 4, yes. No. No. Huh? It's a trapezium. Okay? Right? So, now if it's a trapezium, do you know the formula to calculate the area of a trapezium? Okay, let me warn you. It doesn't mean if you're at grade 11 then you mustn't know your areas of quads. You can get it even in your June examination. I wonder why you moved away. So the areas of quads are still important even though you are in grade 11. You still need to know them. Right? So the area of a trapezium, okay, area Okay, that's OECF. OECF is going to be equal to half. Okay, half times the sum of the two opposite sides that are parallel plus the perpendicular height. The area of a trapezium is equal to half times the sum of the two opposite sides that are parallel times the perpendicular height. So in this case, the height, we know that the height has to be perpendicular to both opposite sides that are parallel. So first we have to prove that this angle, okay, that will be E1 is 90, or we can prove that angle EOF is also 90, but it must be better to prove that this one is 90, because you can use the converse of theorem 1. So I'm going to start by saying E1 is equal to 90 degrees, and my reason, line from center to midpoint of chord. Okay? Right? Now, that will make OE my perpendicular height. Okay? That will make OE my what? My perpendicular height H. Then the next thing now is to write my formula for the trapezium. So the area is given is this. So that's 3 over 4 y squared minus x squared. So I'm substituting the left hand side. Can you pay attention there, please? So this will be equal to half times. Now A, if I consider OF as my A, so that will be square root of 3y. Square root of 3y plus. If I consider EC to be my B, okay, so that will be 2x times the height H. Well, the height H here is going to be OE. Okay? Then, now to carry on here, okay, to carry on, you have to use your knowledge of algebraic expressions. So, I'll write this as 3 over 4 times y squared minus x squared equal to, I'll distribute the half into the bracket, the half only. So I'll distribute the half, and I'll get square root of 3 over 2y plus x times, okay, so square root of 3 over 2y plus x. Where does this x come from? Yeah. Then you've got your OE here. Right. Then from here now, the left hand side, it's a difference of 2 squares. Okay? The left hand side is a difference of 2 squares. So if I want to factorize this, I'll have square root of 3 over 2. Remember, what's the square root of 3 over 4? It's going to be root 3 over 2. The square root of 3 over 4 is going to be square root of 3 over 2. The square root of y squared, it's y. Then here you are going to end up having x times the square root of 3 over 2y plus x. This will be equal to the square root of 3 over 2y plus x times OE. Is that making sense?
Yes.
Okay. Now I'm sure you can see that on both sides this expression appears. Therefore, OE is going to be equal to the square root of 3 over 2y minus x. So this is your answer for OE. So it's just knowledge of algebra. Okay? The only geometry which is here is knowing how to calculate the area of a trapezium, proving that E1 is equal to 90 degrees using the converse of theorem 1. Yes?
So in its text, do they give us the formulas for the area, or do we have to know?
No. The formula for areas of quads are not provided. You have to know them. areas of quads, area of triangle, that's not provided. Yes?
So if you said the E1 is equal to 90 degrees in a previous question, would you still not get the mark?
Okay, I would suggest that you state it again and then just write in brackets proved above.
But what if you didn't, and it's the end of the test now, you're marking, this child wrote it in 8.1.2, but this question is 8.2.
Okay, also you need to look at the mark allocation. I would not give you 5 marks without this.
So,
I would not give you 5 marks without that. If I'm the examiner, I'll be looking for that. Because you cannot start using the formula of area of a trapezium without knowing that the height h has to be perpendicular to the two opposite sides that are parallel. Okay? You have to know it. Yes. Okay, A and B, you can decide yourself whether you want the longer side to be A or you want it to be B. That's up to you. There is no difference. Okay, it's like this. If I give you 2 plus 3, it's what? What is 3 plus 2? Yeah. So whether you make B the longer side or A the longer side, it doesn't make any difference. It can be your choice. Okay. Any question?
No.
Okay, we have got 5 minutes, so let's move on to the next question. Okay, so let's carry on with this question. So you can read the whole story there, right? D1 is that angle. Okay, so we are supposed to find the size of it. Now this is very easy because D1 is alternate to B2. Okay, so you can write here that D1 is equal to 30 degrees in our recent alternate angles. Can you stand up and go outside for a while, please? Then 8.1.2, we need to determine the size of B1. Okay, how did you get B1? Okay, so B1 is equal to C1, that's equal to 60 degrees, and you're using Concord theory. Okay, and then C2, okay, C2 is equal to what? What's your reason for it being 90? Okay, well, in my case, I'm not going to go via that route. I'll use co-interior angles. Okay, because we know B1. Okay, we know B1 and we know B2. So if you use sum of angles in a triangle, it's still fine. But I'm going to say B1, so I'm doing 8.1.3. So B1 plus C2 will give me 180, and that's co-interior angles. Then you state the lines that are parallel. Okay? So C2 will be equal to 180. Okay, sorry, I wrote B1, supposed to be B1 plus B2. B1 plus B2, so let me add B2 here. So C2 is going to be equal to 180 minus 30. Okay, and B1, we got it as 60, so that will be plus 60. So C2 is going to be 90 degrees. Okay.